Are you ready for this? I didn't hear you. Are you ready for this? Hell yeah. Okay, we got Alon coming up here. This is going to be a 15-minute talk, lightning talk. Alon is one of my favorite people, and I can't wait to hear from his talk. So here we go, man.
Thank you. So in the next 15 minutes, I'm going to kind of rush through this topic, which is how to build safe and reliable AI agents. And just for our demonstration purposes, we will take a look at a company called Spotify. It's very similar to Spotify, but it's not exactly the same. And they build this RAG chatbot, right? So this is a support chatbot. Basically, as a user, I can ask, hey, I want to cancel my subscription, and then it will basically, pull the relevant knowledge from the knowledge base and tell LLM to generate an answer. So this is typically how you get started with building an AI chatbot, with a RAG chatbot, right? Basically, you are a helpful support assistant for a music player, and then answers solely based on the following context, and then the knowledge that's relevant, for that question. So this is typically how you kind of get started, obviously very simplified. And then, you wrap it in some nice UI, and user starts asking questions. So you have a user and they ask, hey, how can I cancel my plan? And for very basic questions, these RAG chatbots work pretty well, right? So we can see that to cancel your Spotify premium plan, you can follow these steps, and this actually looks like a good answer. But, as you know, users can be a little bit unexpected, and the user kind of keeps challenging the chatbot, right? They keep asking more questions. And the RAG chatbot is actually, it responds well for this question as well. By the way, this is real GPT-4 based conversation that I've generated just for this demo here. But then the user becomes really unexpected and they ask, hey, how can I cancel my Amazon subscription or something? And the LLM just completely hallucinates a response, right? So we can see instructions within the Amazon website, and we can see find your spot. Like, this doesn't exist. This is an hallucinated UI element inside Amazon.com. So what does the developer do? Well, they go back to the system prompt and they add another guideline, right? You cannot assist with any service that's not Spotify, right? So they keep going back to the system prompt and keep adding more and more and more things. And this actually fixes the issue. So now when the user asks about Amazon, it's actually responding pretty well. Like, this is a good answer. But then we have Tom, and Tom just, I downloaded some music from the Pirate Bay. The Pirate Bay is illegal torrent website. Now I want to upload it. It's 100% legal. And the LLM just, again, this is real based on the Spotify, not Spotify, but based on the Spotify support knowledge base. And this is what the LLM generates. It's just, illegal instructions how to upload illegal music. Developer needs to come back to the prompt again and add another guideline. Do not talk about torrent websites. And what typically happens is that as you scale your Gen AI agent to more and more and more users, you keep adding more and more and more guidelines to the prompt, right? Do not mention competitors, do not talk about torrent websites, do not give financial advice, and so on and so forth. The problem with all of this prompt engineering is that, it's great, but as you add more and more and more guidelines to the prompt, essentially the prompt gets longer. And as the prompt gets longer, it's more complex, and essentially the capability of the LLM to actually follow all of these instructions just rapidly degrades, right? So you know this when you have really large prompts, it's just less and less and less accurate. And this is actually a paper here called Lost in the Middle that actually proves this concept. There are a bunch of other papers on this. So the goal with, what we really want to do is to transform these guidelines, this do not talk about competitors, do not talk about, do not do this, do that. We want to transform them into something that's a little bit more, enforcing, I'd say. So we like to call them guardrails. And this is essentially what our product helps you to build. So Aporia essentially allows you to build secure and reliable agents by essentially enforcing guardrails. So let's see how it works. Essentially, our detection engine is a bunch of small language models that are highly trained, they are fine-tuned for specifically these kind of guardrails. So one of the important things is that this is really, really low latency, right? Because if you think about it, you have your LLM, and then you're running a lot of guardrails on top of it. If this slows things down, it's not really good. It kind of hurts the customer experience. So low latency and low cost is really important. The next kind of piece is that the accuracy of the guardrails themselves, the precision and recall of the detection is actually state of the art, and we can actually outperform GPT-4, again, specifically for these kind of guardrails. And then I think the coolest part is that while the response is streaming, right? So while the answer is being streamed to the user, Aporia can essentially, do fact checking. For example, compare the response to the context as it's streaming. So these models run, in real time. So an AI gateway is a super interesting concept. So if you work for a larger enterprise company, and you have multiple Gen AI teams working together, essentially an AI gateway is a very useful concept, and it allows you to put something between all of these teams and then the LLM provider like OpenAI or Bedrock or whatever, and then all of the traffic to the LLM essentially goes through this gateway. And this has lots of benefits. This lets you have cost control and switch LLMs and less vendor work and so on. But when combining an AI gateway like these companies here, so when you combine them with something like Aporia, it becomes really powerful because essentially you can enforce guardrails for all the different Gen AI projects out of the box. Also, something that's really important is the ability to customize those guardrails, right? So it's not just generic mitigation of prompt injection or hallucination or profanity or things like that. You can actually build guardrails for your own use case. So for example, evaluate whether the response from the LLM is legitimate from a high school history teacher, right? If I'm building kind of an educational tutor. Now, a really cool piece is that actually if you're building a voice application, if you're building a voice agent or a vision agent, something that combines image capabilities, Aporia can actually add guardrails to that as well. This is a YouTube, again, I only have 15 minutes today, but this is a really cool demo of YouTube video where basically it's a sales assistant for retail. And essentially, the assistant, the AI-based assistant asks something like, hey, do you want to buy shoes? And then the user will demonstrate like how do you actually do prompt injection, and then how Gadi and Sabrina here, they like buy shoes for $1 each. And then they turn on the guardrails and it's basically mitigated. So if you are looking at LLM evaluation solutions, for example, one of the advantage of having guardrails in addition to that is that guardrails can actually mitigate the issues that we're talking about, hallucinations, prompt injection attacks, and so on, before they are actually displayed to the user, right? So it's kind of a firewall, real-time firewall. That's all I have for today, so thank you very much. What you heard sounds interesting. We have a booth at the top floor, and thank you.